Good morning. Hello students. We are going to discuss about one concept known as maximum delay constraint in VLSI design. So in sequential circuits, we'll have sequencing elements like flip-flop 1 and flip-flop 2. So first we'll discuss about flip-flop based sequential circuits. This is the circuit is given. Data D1 is given input to flip-flop 1, then flip-flop 1 output Q1 is getting, then Q1 is given to combinational logic 1 or combinational logic, then its output D2 is given to the next flip-flop. So the duration of one flip-flop to another flip-flop is TC, is the one cycle of the time. Now, maximum delay means what? Whenever data D1 is given to flip-flop 1, it will take some delay. Let us take X delay it is taking. Then when the data Q1 is given to combinational logic circuits, it will taking some delay. Let us consider Y delay is taken. Then flip-flop 2 is there. It has some setup time for taking input the data. The data must satisfy the setup time. Let us write that in S. Then this is the delay, total delay is taken by this from D1 to D2. That delay must be less than the total clock cycle TC. If it is less than, then there will be no issue, we'll get a correct output. So that equation, if we'll find out, from that equation, we'll find out what is the maximum delay will be given for the combinational logic. That will be known as your maximum delay constraint. Now come to understand in terms of timing waveform. Now see, this is the clock signal is given. At the rising edge only, the flip-flop will be active. This is clock cycles are P1 you can write first rising edge. This is the second rising edge. Now, when the rising edge is coming, the data D1 is given input. So we'll get some output after some delay, we'll get the output. This delay is known as TPCQ, propagation delay from clock to Q. Now Q1 is getting ready. So Q1 is given input to the combinational logic. Combinational logic will have some delay that is known as propagation delay. Now, after the propagation delay, the output will be known as D2. D2 is stable output at D2. Now, when the D2 you are getting, there should be some time with respect to flip-flop 2. For example, flip-flop 2 will be active at this point, this rising edge. So before some time, this time we are considering here, before this time, at this point, the data which is given input to the flip-flop 2 must be constant, which is constant in this case. Then we'll get a correct output. But if we are not getting the data before setup time as constant, then we'll get an incorrect output. So what are the different cases is possible? For example, instead of data is stable at this point, if data is moving like this and it is stable at this point, from this point it is stable. Our setup time is this one. See our setup time, but the data is stable at this point. That means it is violating the setup time violation. Then we will get an error. Only the setup time, propagation delay, TPC code together. If it is TC, then only there will be no errors. That means if the propagation delay wherever it is reaching, from there we are getting the setup time rule is satisfying for the flip-flop 2, then we get the correct output. Then what is the total delay? TPCQ plus TPD plus T setup. It must be less than the total cycles. Because before this TC on before this rising edge, the signal D2 must be ready. So it should be less than equal. If equal means that is the extreme time, extreme delay. So now if we find out TPD, be less than TC minus TPCQ minus T setup, or we can combine this one plus. This is the maximum delay that can be given to a combinational logic without an error at the output. And this PCQ is with respect to flip-flop 1, propagation delay. The setup time is with respect to flip-flop 2. This is belongs to the sequential elements. So this together, this delay is known as sequencing overhead. Overhead. Okay, this is all about the maximum constraint delay or maximum delay constraint of flip-flop based.